Start this here. All right. Oh yeah, because of our delayed gratification scheme, already done this one. I also this morning there were some questions about this question on the assignment. It's question 4, where it's just like flexing your algebra muscles, and so it's just for practice. This type of calculation is not on the final exam, so it's just to kind of I don't know, use these summations. I had used this question in the past, and when I looked at it, I was, they can figure it out. Now, hindsight, I probably shouldn't have done that, but whatever. You live and you learn. From the formula sheets, because you have these summations down at the bottom, right? You have the sum of x, you have the sum of y, you have the sum of the x squared, you have the sum of the y squared, you have the sum of the sxy's. So you have all those sums. And so to find the correlation, you can use the sum of the xy's, you have that, minus the sample size, 10 times x bar times y bar, you have all those values. The sum of the x's squared you have x bar squared, you can find that. Sum of the y's squared, right? So you have all these components. It's really just kind of pulling those sums and putting them together. For the standard deviation, we were using this formula more, right? But another way that we could write it is with those sums. So the sum of the x's squared, and it's been here right under our noses this whole time, right? But I usually give you the standard deviation, and on the final, I will not make you find the correlation unless I give you the r squared and then I ask you what's the correlation, which is the square root, right? That we saw last day. And so here, right, I just kind of plugged in these values to show you how to use this S formula, blah, 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 blah. Yeah. So I know that one's kind of wreaking havoc for some. So just wanted to put it in there because I copied it from this morning. Ta-da! It's pre-written. It's our last new material. Maybe I should make a sad face. No, it's always like a nice time, but I'm sad. Just one lonely tear. Teardrop tattoo. No. So multiple regression is, of course, when we have multiple predictors, and so more than one x. Yeah. And so often we're going to need more than one predictor to be able to explain changes in y, right? The simple linear regression, which we've looked at so far, right? You can get a pretty good line of best fit with just an x if the x is a really good predictor of y. But usually that's not the case. You have a collection of many x's that do a so-so job of predicting y, but together, right, we can learn a lot about y. Why? I'm just going to steal this loans data set from the textbook, but I feel like we established the last day that that's pretty safe. So the loans data is, I think, pure lending data. So basically, people are applying for loans. Oh my gosh, come on. Just want. Okay. It won't let me grab it there. So just to talk about the loans data here briefly. Lots of variables. We're looking at a subset of the possible variables. That's okay. So we've got information on the 10,000 loans. The loans data is probably available. There's an Open Intro package. If you install the Open Intro package, you could probably access the loans data just through that. But we're not going to do that here. But I'm just thinking if you wanted to kind of link what we say here with what you're doing in 310. So we're focusing on things like the interest rate. In fact, we want to predict the interest rate given some information about the applicant. Okay, so some of the things that we are going to talk about are the income verification. Here, let's say, so the interest rate is, of course, numerical. And I'm going to tell you that this is going to be our y. So our response variables. We want to predict the interest rate for a person of some kind of combination of these variables. So the income verification, I'm not going to bring it in, but we can look at it here, is a categorical variable describing whether the borrower's income source and amount have been verified. So the levels, so there are 3 levels, verified, and then source only. So then just the source was verified, but not the amount, or just not verified, right? So there are kind of multiple options here. Then we have the debt to income ratio. If we look at the debt to income ratio, it looks numerical. Going back to ours here. So this is, of course, categorical, and then we have some numerical variable, taking us way back to the beginning of the course, right, where we would just had a data set like this and we had to figure out which one's which, right? Credit utilization, I'm assuming, is numerical. Bankruptcy is a dummy variable, right? 0s and 1s. And so it's a 1 if the person has declared bankruptcy, it's a 0 if they have not, which explains why there's so many zeros there, and then just the 1, 1. But this is binary, which of course is categorical, but sometimes I like to specify if it is binary. Term is kind of interesting because there are kind of term options, right? And so if you wanted to, you could treat it as categorical, but I happen to know from this morning that they treat it as a numerical variable, right? So if you wanted to treat it as a categorical variable, you'd have to tell it that treat this as a factor, and then it would do it, right? But it is numerical, right? Or categorical if you need it to be. You're usually safe to just keep it numerical though. The date it was issued, or at least the month, is categorical. And then the number of credit checks is numerical. Now with you guys, I kind of stalled out. I redid the binary example, but what I actually want to do is just look at still simple linear regression, but with a categorical variable with the 3 levels. So what we're going to use the income verified, right, with 3 levels, and just to see how it works. And then I find that that helps explain kind of when we take it to more than one variable, how it works. So where is it? Yeah. It's a lot of stealing from the textbook today, because it's all output anyways. So if we use the income ver, right, there's 3 levels. And so what happens is we use one of the levels, and usually it's just automatically decided using R often, right? But I think any software that you use, you could specify which one you want, but usually you just let it pick whichever one it wants. And in this case, right, we know the options are source only, verified, or not verified, right? And so then I know that this intercept is really kind of a placeholder for not, in a sense, right? The not category. Each of these, right? Each of these options now, or maybe I should say not the not, but each of these, right? It either is source only or is not, right? So now these have been converted to binary variables, right? So these guys are binary. And this not, which is now the intercept, just like we don't remove the intercept from just a simple linear regression, we need some anchor. And so that's how the intercept is still working, but it absorbs and it takes the place of one of the categories. Okay. And so how we interpret the source only, for example, is if the source only was verified, then the rate, the predicted rate would be 1.416% higher than if it was not verified at all. Right? That's stealing this from the textbook, but it's counterintuitive, right? When I first looked, I'm like, oh, okay, that's weird, because we kind of assume that if the income is verified, then that's a good thing, right? But maybe there are underlying reasons why these things are positive, right? Because this is saying that the rate, the predicted rate, is going to be 1.4 higher or 3.3 higher if it was verified in some way, right? And so that's kind of counterintuitive, right? But it's using the not verified as a jumping off point. Yeah? And so that's kind of weird. We have p-values for all of these, and all of these are going to be significant. So they're all significant predictors for the interest rate. So what can we do here? The predicted rate, we can use this output, we can use these coefficients or the estimates to write out the least squares regression line here, whoops, which is 11.0995 plus 1.4160 times source only plus 3.2543 times verified. So what happens is that this is going to be the not prediction, right? If it's not verified, your predicted interest rate is 11.0995, because then these are both zero, they're gone, right? It can only be one of these three things. Okay. However, if we look at the 1.416, this is the increase in the predicted rate if source only is 1. So what kind of tends to trip people up, I know, is okay, well, if source only is 1, then I should definitely turn off the verified, right? Turn that to 0, which makes this section go away, right? But then how do I turn off the not? Well, we don't, right? Because it's baked into the intercept. So now you don't have to turn it off. You can just say that, okay, then I'm going to flick the switch and I'm going to turn the source only on. And then I get this additional 1.416% increase. Whereas here, the 3.2543 is the increase in the predicted rate if verified equals 1, right? Because if it has been verified, then source only is off because it can only be one thing, but it's on top of the not, which is the jumping off point. A little bit tricky is, so for regression, right, for this reason, you don't want to have all k levels, right? If you have multiple levels in a categorical variable, if you include all of them, then that messes things up. And so we use k minus 1 of those levels, and then the one that doesn't have its own coefficient is called the reference level. Right? Kind of fine in this scenario, but what happens if I now incorporate all these other variables, right? And so what if we want to make a model that looks something like this? Technically they're betas, but we estimate them using software. Yeah. So now we're using all these different variables, right? We've got the intercept again, and then we've got this beta 1 and the income source only and the income verified, right? But this is really from one categorical variable, which is income ver, right? This one. So again, this not verified category is lumped into the intercept, right? So it's going to be a jumping off point. Where it gets confusing though, or at least to me, used to be very confusing, is that it's not just going to be for the not verified, it's also going to be for the missing level in the date that it was issued, right? And so the levels that we have here are January, February, March. And so the intercept is not just the not verified, but it's also for February 2018, right? So it's a combination of those two. Well, what if one of those aren't true? That's okay, right? And so that's what I want to play around with. So here, this is the issued, right, which has 3 levels as well, right? All the other ones are numerical variables, the debt to income ratio, the credit utilization or something. The bankruptcy is binary, so that's fine, right? It is its own on-off switch, so it only needs one coefficient. And then the term they're using as numerical, that's fine. And then the credit checks is also numerical, right? And so what this looks like in terms of output is something like this. So now we have all these estimates of the coefficient, and from here, right, we can do things like we can check the p-value, which we'll leave for a later course, classic, right, that kind of thing. Which ones do I keep in this model? Because eventually what we'll want to do is reduce the model so that we have the simplest possible model that still does a good job of predicting, but that's for another time. Okay, so what we said was, okay, so here, this intercept is both a placeholder for not verified and February 2018. Oops, whatever. Yeah. So those are jumping off points, and you can have a collection of things as your intercept, right? It's just a starting point. Now what we want to do is we want to be able to use these estimates to predict some outcome. Right? And so, right, we can still have the actual rate that an applicant received. I can have some information, so some input information for these that I can multiply by the coefficient. So it extends just like we did before, but now I have multiple x's and multiple coefficients, but otherwise it stays the same. Which means I can find a predicted value. I can find a predicted interest rate. If I have an observed and I have a predicted interest rate, I can find a residual, and that is how this these estimates are found, right? Kind of a catch-22. We find the coefficients or the estimates that minimize the residuals, right? Or the sum of the squared residuals, right? So to kind of put it into context, oh, it's not there. I want to show how to find the predicted value of the first observation. Once I cropped up this and this. This morning I went in blind and I just picked the first observation for a few reasons, but I think it is the first observation for this reason. But luckily they have found the predicted value, right, for us, so it all worked out. Otherwise I'd have to plug all these in. Why did I choose the first observation? Because I want the verification variable, I want it to be something other than not verified, right? Just to show how it works. And in this case, it is verified, so it'd be here, right? And then the issue date, I would want it something other than February, so it's not the jumping off point, but we can play around with it, right? But so what we do, we know the interest rate, right? This is the observed value of y. Okay? So here. Yeah. So what we can do is I can plug in each of these observations, and of course in R, you would use your predict function, and it would just find all the predicted values, right? Or you can just get straight to the residuals if you want to. But for here, the intercept is always there, right? So we never exclude the intercept. It's always in our calculation. So that one is, we're stuck with that one. For the income verification, it's verified. So what we do is we set this to be 1, which means the source only can't be on. It can only be one of these things. So I set that to 0. The debt to income ratio for the first observation is 18.01. So 18.01. Should have reminded myself what this one is. Credit utilized, something like that. Utilization. Credit util. Credit util. Turn Finnish all of a sudden. Credit util. 0.55. Bet you didn't know I did such a spot on Finnish accent, huh? I know. But who would know? No one. Bankruptcy is a 0 in this case, right? And because it's binary, it just needs one coefficient, right? Because we turned all those other ones into binary variables. Oh yeah, the difference between regression and things like often machine learning, we use one-hot encoders where you have a binary variable for every categorical variable, but then that would introduce multicollinearity where they're exactly correlated and we know everything. So in regression, we remove one of them. So we do the same thing, but we remove one of them because otherwise it makes a mess. So it depends on what you're doing. Sometimes you keep all your binary categories in there, right? Depending on what you're doing. In regression, we remove one of them because otherwise we know too much. For example, knowing that all of them are off means that the intercept is on, right? The term is 60. It was issued in March, which means that this guy is a 1, which means that this guy is a 0. And then the credit checks, there were 6, whatever that means. So now, if I went ahead and said, okay, I'm going to take 1.9251 plus 0.9750 times 0, right? Plus 2.5374 times 1 plus 0.0211 times 18.01, et cetera, et cetera, et cetera, right? What we would find, and this was such a relief, is that the predicted value of y, whoops, is 18.09. So we predicted an interest rate of 18.09, whereas the actual interest rate that they saw was 14.07, which means we could find the residual is the observed minus the predicted, 14.07 minus 18.09, which is negative 4.02. Don't worry, I did not do that in my head. I stole it from here, where I was so happy to see that they had already done that prediction, because that's the kind of boring math you don't want to do. I make you do a lot of boring math, but not that. I shouldn't say that. I will make you do it, but for way fewer coefficients, right? Reasonably, kind of 3, 4 coefficients, right? If I give you the output, then I do expect you to be able to find the predicted value using those, but I give you the inputs as well, right? Yeah.
So the intercept here, the jumping off point.
Yep.
All the categorical variables.
For everything. And that's the brain teaser.
Okay, so there where you say not verified and then February 20, that kind of makes sense to me.
Yeah.
How do you decide
what
is the jumping off point? Like what if it was credit card type and then MasterCard and Visa?
So in order to figure out which ones are kind of lumped in here, you don't really need to, because you would be looking for February 2018 as one of the options here, and you would see, oh, it's not here, then it must be the intercept. But it helps to know what the levels are, because then the one that you don't see here is going to be the intercept.
Okay, so you have to look at your R.
Yeah, and R just picks one that it wants to use.
Okay.
So you just, unless you force the order of the factor, then it would, yeah. Yeah.
Oh, so everything.
Or the top, yeah, maybe the top, but one of the two. Yeah, so yeah, it's not necessarily the not verified and February 2018, but I don't know how else to say it. It's kind of this placeholder. So just like we have the y-intercept when we draw a line, right? It's doing the same thing, but because we have categorical variables, it gets weird, right? So if you think about, if you don't have any categorical variables, we would be okay with there just being an intercept, right? We would say, oh, well, that's if everything is 0, right? But then with categorical variables, right, it's not going to work anymore. So it's just an extension, but I find that it's really hard to wrap your head around what the intercept is in this
Yeah.
case. Yeah.
And so if they're not there and the version 18 is because in those instances, there's more than 2.
Yes. Yeah. So so in R, what you would do is you wouldn't write out each of these. So if we because I know you have to do it in R. So what you would do is you would say whatever the interest rate variable. In fact, maybe I'll do this. I'm just gonna grab this. Put this one back on there, but so if I do the LM command on the interest rate, tilde income verification plus the debt to income plus the credit doodle plus the term plus the issued plus the credit checks, it will just generate those levels because it'll know that this one and this one are categorical. So you have to tell it that they're factors. But if it knows that they're factors, then it'll just look at the levels and generate a coefficient for k minus 1 of the levels. So here, so this is what you would, I mean, there's like data equals blah, 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 but I think you kind of get the gist. Okay. And then here are nodes to generate coefficients for k minus 1 of the levels. And then same thing here.
We put in brackets next to levels factors.
Yes, of course. And then ditto. Is that a cop out? Or I don't even need to do that. I can just copy what I said here.
This is only for if there's more than 2.
Yeah. Because, oh, say that again.
More than 2 options within category. So we're
Yes.
binary logical.
Yeah. Yeah, because the bankruptcy is binary. And so it'll just have its own built-in 0-1 switch, right? So it only needs only gets one coefficient. The idea is the same. I have 2 categories, so I do 2 minus 1 coefficients for it, but only gets 1 coefficient. 2 minus 1.
Follow up.
Yes.
Here you use a plus between each.
Yeah.
Dependent.
Yeah.
Satoshi was trying to explain it to me, but I didn't quite understand multiplication between.
Oh.
And then division as well.
Okay, division.
Yeah, it was weird. The division, maybe he's like, I don't think this is important, but the multiplication of colon.
Yeah, the multiplication, what's the difference between multiplication and the colon, I wonder? I know that it's an interaction term when you multiply them.
Yeah,
right.
There's the 2 coefficients come together.
Yeah.
And keep the outside coefficients as well. and then the colon is just the middle.
Yeah, it's the colon introduces the identity matrix, I think.
I don't understand. Can you really, is that beyond us at this point?
Yeah, I know you do use the colon. I have used the colon. I use the multiplication quite a bit because just in a simplified scenario, right? What if I do the LM command of the rate to the income ver plus the debt to income DTI, let's call it, plus technically so if you wanted to, you could just go multiplied by DTI, and the model that it generates is it says, fine, you want to have them each individually, and then you want to have the interaction term, right? And so what it does is it generates this model, which is the rate equals, or the predicted rate, whatever, is the do you guys want with betas or without betas? I can do it in words. The intercept, let's use the estimates. The names of the estimates is going to be the intercept plus the same deal, income ver, and what were the levels? Source only, that's source only, plus, so it would still break them out to verified, plus DTI, plus, would have been nicer of me to use the binary variable. It extends to multiple categories, but are you guys okay if I change this to bankruptcy? Just so I don't have to deal with writing. So
Does the categories, takes out the categories for you, is that what?
So the multiplication does, yeah, so it does this, but then it also adds the final interaction term. You know what? I've made it this far, and I've got the technology. Let's use it here. Okay. Let's get this over here. So times DTI plus times DTI. I'm pretty sure that that's what it would generate if you had these multiple categorical levels factors and multiplied by numerical variable. So what you would do is exactly this. So this would have some coefficient. So now I'm going to throw in these coefficients, beta 0 plus beta 1 plus beta 2 plus beta 3 plus beta 4 and beta 5. So let's say that we want to do it for that first, if we want to use this to predict for the first observation again, right? Then we know for the first observation, the predicted rate, I don't have values, but it's going to be whatever the estimate for beta 0 is, and what was the income verification? It was verified, right? Which means that the source only is 0. So that means I have plus whatever the estimate is times 0 plus beta 2 times it was verified, so times 1 plus beta 3 times whatever the DTI was. So far it's all the same, 18.01 plus make more room here. Beta 4 times, so the source only is still off, right? So you've got some value here. Hopefully that's okay, but from your output, the source only is still off. So it would be times 0 and then literally times 18.01. Because you're allowing them to, you say that, okay, well, they're probably moving together, right? That's when you would include an interaction term. Plus beta 5. And then this one is 1, so times 1 times 18.01. Does that
Get it?
help or hinder? Uh-oh. It's like my nephew, he can be convinced of anything. Yeah, it's like, oh, was it like this? He's like, and then you say something else, he's like, no. Yeah, it's like, so you want to go to bed then? He's like, no. But it always starts like, yeah, no. Pretty funny. We use it all the time now. So that's how you guys are feeling? No. I didn't get a chance to mention the adjusted R squared in the morning section, so it only seems fair that I don't mention it to you guys either. It's the R squared, but it's adjusted and you're penalized by the number of predictors. And there, can close the book on new material. Crazy. All right. I should have said R squared, but it doesn't seem fair. I didn't say it in the morning. Won't say now. Well, on that note, I'll stop this recording.